The name of our project is NextGen MCPTT. We're in Contest 2. We have 2 members on the team. Our team leader is Professor K.K. Ramakrishnan from UC Riverside. He has 40 years of experience on networking. I'm Jiazhen Chen. I'm a postdoc at WinLab Rutgers University. Our common research interest is to enable powerful and convenient mission-critical communications for the first responders. In this project, we address 3 issues with existing MCPTT systems. They have been repeatedly mentioned as critical functionalities needed by first responders in many of our interviews and demos, including at PSCR meetings. The first issue is that messages cannot be stored or replayed. When the receiver isn't able to hear it clearly, he is forced to ask the sender to repeat. This not only wastes communication channel resources, but also the precious time of the first responders. The second is, when a first responder needs to focus on some task and come back to the interaction later, he cannot pause the messages and play them when he is ready to listen. The third issue is the difficulty in serializing speech, especially on a connection with long delay, for example a satellite link. First responders end up wasting a lot of time waiting for the floor or just talk over each other. To address these issues, we substantially enhance the existing mission-critical open platform, or MCOP, with our innovations. First, our application stores the messages that are received. This allows the user to pause the playout and replay when desired. Second, we allow users to push and talk whenever they want to. Our application monitors the availability of the channel and sends the user's messages when it can acquire the floor. We also take advantage of cloud-based speech-to-text and text-to-speech capabilities to make it more convenient and thus accelerate communication among first responders. Here is an exhaustive list of the functionalities we have completed so far, just for record. We'll go through many of them in the technical demo section. We got a chance to demonstrate our application and have first responders use it in a disaster city exercise at the Texas A&M University in January. Here is some feedback from them. They really like the features we have provided in our application. Now, we'll show you the details of the application via screenshots and videos captured using Android emulators. This is just for the best presentation quality. We have also tested our application on Android phones, tablets, and Chromebooks. Our application has evolved from the original app in MCOP SDK while still retaining backward compatibility. The new design chooses to mimic typical messaging apps so that it is intuitive and the users do not have to spend time learning how to use it. Please note that we're not just creating yet another messaging app. Instead, we have made a lot of effort to enable the innovative features on the traditional MCPTT channel so that the first responders can still feel that they're using their familiar and dedicated channel. Moreover, they can take advantage of the screen and data capabilities of smartphones to provide just the right functionality they need. Let's look at the demo of a select set of our features. Here, we have 4 devices representing 4 users. From left to right, we have Alice, who is using original app from MCOP SDK. Bob, firefighter, Charlie, EMT, and Ed, commander, are using our application. In the interface, we use intuitive aliases so that the first responders do not have to remember MCPTT IDs. Just for demo purposes, at the bottom of each device, we visualize the audio input and output to help distinguish the messages from different devices when they're playing at the same time. All the users are now in a group call, and Alice is going to push and talk. You can observe the microphone input on Alice and the speaker output on the other devices. Bob, I believe Tech to Protect will make a valuable contribution. You can see that our application is compatible with MCOP, which means we're working on a dedicated MCPTT channel. For each message received, our application performs speech-to-text in the cloud. If Bob did not hear the message clearly, he can look at the text. To make it easier for the users, we also put the sender name and length of each message at the top. In addition to speech-to-text, we also store the message audio received. If the text is still not clear enough, Bob can replay the message by clicking the message body. Bob, I believe Tech to Protect will make a valuable contribution. Since we store the messages, they'll be available for future use, such as supervisory review, evidence, etc. Let's assume that Charlie needs to focus on a task now. He can click the Do Not Disturb button highlighted on the screen. Now he is in the Do Not Disturb mode. Let's make Alice speak again and you will see that the message is buffered on Charlie. You can look at the speaker output. Are you going to participate in the effort on November 15th? Although the message is buffered, our application still turns it into text so that Charlie can take a quick glance if he has time. The pending messages are marked in green. Charlie can also allow some users to override the Do Not Disturb mode by long-click the Do Not Disturb button. Currently, we allow messages from emergency calls to override. Now, let's add Commander Add into our override list. Now Commander Add is added to the override list.
Yes, of course, I will try my best.
We can see that the message from Bob is still buffered since he is not on the override list, but when Commander Add wants everyone to evacuate, you can see that his message will be played on Charlie.
Team 1, evacuate immediately.
When Charlie finishes his task, he can exit the Do Not Disturb mode. The pending messages will be played one after another.
Are you going to participate in the effort on November 15th?
Let's skip the remaining messages for now. Now Charlie can reply using text-to-speech or SMS if he is in a situation where it's difficult to speak. Let's try text-to-speech first. Now the application is synthesizing the text into speech using IBM Cloud. It will then send the voice over the MCOP channel. You can see that even Alice can receive this message.
From Charlie, EMT. I'd love to participate also.
Charlie can also choose to send SMS. You can see that the SMS is sent to Bob and Ed. This message is delivered via our own server as text directly, but Alice does not receive this SMS. The server provides a report to the sender indicating how many units have received the SMS and how many are still pending. When the unit is offline, the pending SMS messages will be buffered and delivered when he or she logs back on. On receiving the SMS, the application on Bob and Ed uses the cloud to synthesize the text into speech. This action is performed separately on each device, so that you will hear that the messages are not played at the same time.
Text message from Charlie, EMT, to football match security. Can you send me the agenda, please? Can you send me the agenda, please?
Some users can also choose not to enable this capability due to the limited bandwidth or cloud capacity. We believe that SMS would be very helpful, especially in disasters where the channel is busy, since text messages are much smaller compared to voice messages and quicker to deliver. In the second scenario, we show that our application allows Commander Add to send a message even when Bob is occupying the floor sending a long report. Now, Bob is going to start his report. Both Charlie and Ed will hear the message.
From Bob, firefighter. We have an incident that needs EMT support. There are 3 people needed to be rescued.
Now, Ed just pressed the push to talk button. The playback will be paused on his side so that he can record the message to send.
From a house fire.
Charlie,
the 2 adults were upstairs and the third child was down.
Now, Ed releases the push to talk button. The outgoing message is buffered and the playback of Bob's message continues. You can hear that the playback on Ed is about 4 seconds behind that of Charlie.
Downstairs in the living room. We had to go in and rescue the child first, who was...
Now, let's assume that Bob just finished the report. The application on Ed will find out that the floor is available. It will send the buffered message while still playing the message from Bob. Remember that he paused for around 4 seconds to record the outgoing message.
Location. Please let us know as soon as the ambulance is on its way.
And support Bob. That was the asynchronous send scenario. As future work, we'll also indicate to all recipients how long this message was delayed to acquire the floor. Compared to the first responders that use smartphones, dispatchers usually have devices with larger screens, for example tablets. You can see that on these devices, we take advantage of the extra screen space to show more information. In addition to the basic messaging features shown on the right, we show the geolocation of the first responder units in the middle, dynamic group management on top left, and unit affiliation management on bottom left. When we want to locate a unit that is not in the current view, we can click the Locate button, and the unit will be centered in the map. We also allow the dispatcher to show the location of every unit in a group by clicking the Group Location button. For units that are currently offline, we show the time and location of his or her last check-in. We allow the dispatcher to dynamically create a group. You can see the new group shows up in the group list. We also allow the dispatcher to affiliate units to the group. Now we have Bob and Charlie in the new group. The first responders can now use the new group to communicate. You can see the new group appears in the list of destinations you can call. Now let's send a message to the group. You can see that the message is sent to Bob and Charlie. The application will synthesize it to voice, but we skip this step here. The new group is also visible for Bob and Charlie. When Bob sends a message to the group, Charlie, the other member of the group, will receive it. The dispatcher can also add Commander Add into the group. When he sends another message to the group, Add will also receive it. We also have a number of other functions. Let's scan through them quickly. They include making emergency and normal calls to groups and individuals, and dynamically upgrade/downgrade during calls. Call prioritization. We allow the incoming emergency call to override an ongoing normal call. Login using biometric information. The first responders can use their fingerprints to fill in the username and password automatically in the login page. As for the next steps, we expect to enable device-to-device communication on top of the existing application. Direct mode was considered very desirable when we talked to first responders. We'll test and evaluate the application to ensure the scalability. On the website, we'll create tutorials for users and showcase the functionalities. To get more exposure, we'll collaborate with first responders and Disaster City on the training exercises. We'll also publish our project on the FirstNet app catalog to allow first responders to download and try it in their regular work. We have been making steady progress since November last year when we participated in an in-person contest in New York. In the next 6 months, we'll try to use the seed funding to execute our business plan and push the application to the field. Thank you very much for your attention. You can find our project website with the address shown below, or just scan the QR code. We're happy to take questions now.